Lesson 13-4, Compound Probability. Here's the warm-up for today. Please pause the video until you're ready for the answers. The first problem has the word or in it. The second problem has the word and in it, so it makes these questions different. In this case, we could just get a vowel, or we could get a vowel and a head. So there's more possibilities on the top question. So the vowels are A and E on our spinner. So we have 2 out of 7 options. And getting a head, there's only one way out of 2 to get heads. So we add these numbers to get 11/14, which is 78.6. In the second example, you have to get a vowel and get a head. So that's a little bit harder. So in this case, we want to multiply. So whenever you see or, you add. Whenever you see and, you have to multiply because both events have to happen. So in this example, we get 14.3%. So in this lesson, we're going to be describing events as subsets of a sample space using or, and not. We're going to understand conditional probability using the word given. And we're going to be finding conditional probability. So one of the things we need to look at is independent events. When 2 events, A and B, are independent, the probability of both occurring is the probability of A times the probability of B. So here are some examples. Landing on heads after tossing a coin and rolling a 5 on a single-side die. Choosing a marble from a jar and landing on heads after tossing a coin. Getting a 3 from a deck of cards, replacing it, and then getting an ace as a second card. So these are some examples of independent events where the first event does not affect the second event. They are independent of each other. So here are our key concepts. A compound event is an event that is made up of 2 or more events. Independent events is the occurrence of an event that does not affect how the other event occurs. So another example is flipping a coin and spinning a spinner. One will not affect the other. Dependent events is the occurrence of an event does not affect how another event occurs. Excuse me, it does affect how another event occurs. So lightning and golfing on a golf course. So if there is lightning, that will affect whether you're going to golf or not. So these 2 events would depend on each other. So let's decide whether the events are independent or dependent. Number 1, picking a card from a standard deck of cards, then choosing another one without replacing it. I would say this is dependent. On the first draw, you're going to have 52 cards, but you're going to keep it. So on the second draw, you would only have 51 cards. So the sample space changes. Number 2, picking a card from a standard deck of cards, then choosing one once the first card is put back in. So this is called replacement. So we have 52 cards to pick from right away, and then the second draw, we also have 52 cards because we're going to put the one we drew back in the pile. So I would say these are independent events. Picking a card from a standard deck of cards, and then tossing a coin. Picking a card is not going to affect whether we get heads or tails, so these 2 would also be independent. Finding the probability of 2 independent events. If A and B are independent, then the probability of A and B is the probability of A times the probability of B. My desk drawer contains 5 red pens, 6 blue pens, 24 silver paper clips, and 16 black paper clips. If you select a pen and a paper clip from the drawer without looking, what is the probability that you select a blue pen and a black paper clip? So here's what we want. The probability of a blue pen and a black paper clip. So that means we want the probability of the blue pen plus the probability of the black paper clip. So there are 6 out of 11 ways to get a blue pen, and there are 16 out of 40 ways to get a black paper clip. This is what it would look like if we could tell what we were grabbing, if it was a pen or a paper clip. So I'm going to assume that when we feel around, we know whether it's going to be a pen or we know whether it's going to be a paper clip. So this fraction turns into 12 out of 55, which is approximately 21.8%. Please pause the video and try this problem. So we want a number less than 3, which would be 2 out of 6, and the spinner landing on a vowel. So 1 out of 4. So we don't want to reduce, we just want to multiply and then we can reduce. So I get 2 out of 24, which is 1/12, which is approximately 8.3% chance of that happening. Mutually exclusive. They are events that cannot happen at the same time. Tossing a coin and landing on both heads and tails at the same time. That cannot happen. If events A and B are mutually exclusive, then the probability of A and B occurring is 0. Then the probability that either A or B occurs is the sum of the probability of A occurring and the probability of B occurring. So if it's mutually exclusive, the probability of A and B is equal to 0. The probability of A or B is equal to probability of A plus the probability of B. I have 8 tiles numbered 3 through 10 in a bag. What is the probability of randomly choosing a tile that is both an even number and a prime number? Well, let's analyze this. An even number would be a 4, a 6, an 8, or a 10. And a prime number in this case would be 3, 5, 7, and 9. So are these two events mutually exclusive? Well, they can't happen at the same time, so I would say yes. So then our probability of both of those things happening at the same time is 0. The second question, what is the probability of randomly choosing a tile that is an even number or a prime? Well, an even number was the green, so that's 4. A prime number was a pink, and I don't think 9 should be on that list. 9 has factors of 3, so then I have 3 out of 8. So we get a total of 7/8, which is 87.5%. So these two events are mutually exclusive. The tank at the aquarium holds a variety of fish, which 24% are catfish, 13 are black tetras, 8 are angelfish. What is the probability of randomly choosing a fish that is a black tetra or an angel? So we want the probability that it's a tetra plus the probability that it is an angel. So you can't be a tetra and an angel, but you could be or. So this would also be mutually exclusive. So probability of being a tetra is 13%. Angelfish is 8%. So we get a total of 0.21 or 21%. A teacher surveyed students to determine where to go on a field trip. 24 wanted a water park, 33% preferred the beach, and 24% preferred the zoo. What is the probability of randomly choosing a student who prefers the beach or the zoo? So beach was 33, zoo was 24, so our answer is 57%. Please pause the video and try this one. Here is the answer. Overlapping events are events with outcomes in common. For a standard number cube, the event of rolling an even number and the event of rolling a multiple of 3 overlap because a roll of 6 works for both events. So how to find the probability of overlapping events? The probability of A or B happening will still be A plus B, but you have to subtract out the overlap. So here is the overlap. So let's find the probability of some overlapping events. Again, I have 8 tiles numbered 3 through 10 in a bag. What is the probability of randomly choosing a tile that is both an odd number and a prime number? So the probability of being an odd would be 1, 2, 3, 4 out of 8. The probability of being prime would be 1, 2, 3 out of 8. So this is an and, so we want to add them. But now we have to subtract out the overlap on that. So is there any numbers that are odd and prime? Well, it looks like we counted the 3 twice, we counted the 5 twice, and we counted the 7 twice. So we have to subtract 3/8. So it looks like this is going to be 1/8. Did anyone catch my mistake on that? I did the formula for an OR, where we added the 2 together and we subtracted out the overlap. If we're going to do an AND, then we have to multiply. So let's just move on to the next one. The chess team consists of 5 12th boys, 7 12th girls, and 1 4th sophomores. What is the probability of randomly choosing a member who is a boy or a sophomore? Here would be the solution. Please try the last slide.